In this video, we'll talk about the sum and difference identities in trigonometry. So I've listed out the 6 sum and difference identities. Let's go ahead and work through a few examples and see how to use these. Let's say we want to find the cosine of 75 degrees. We can rewrite this to be the cosine of 45 degrees plus 30 degrees, since 45 plus 30 adds up to 75. So if we refer to our cosine of A plus B identity over here, we can rewrite this as the cosine of A times the cosine of B minus the sine of A times the sine of B. So let's write that. We'll have the cosine of A, so A in this case will be 45 degrees, times the cosine of B, B will be 30 degrees, minus the sine of A, so A is 45 degrees, times the sine of B, or B is 30 degrees. So if we think about our unit circle, let's draw it over here. If we have 30 degrees, the angle 30 degrees, the x, y coordinates on the unit circle are square root of 3 over 2, comma 1/2. And then if we think of the angle 45 degrees, the xy coordinates on the unit circle are square root of 2 over 2 and square root of 2 over 2. So recall that the x coordinate corresponds to cosine, while the y coordinate corresponds to sine. So the cosine of 45 degrees is the square root of 2 over 2. So let's write that, the square root of 2 over 2. And this will be multiplied by the cosine of 30 degrees. So the cosine of 30 degrees is square root of 3 over 2. And then we have minus the sine of 45 degrees. That would be square root of 2 over 2 times the sine of 30 degrees. So the sine of 30 degrees is 1/2. Okay, so let's simplify. We've got square root of 2 times the square root of 3. So that's just the square root of 6. In the denominator, we have 2 times 2, that's 4. And then this whole thing minus the square root of 2 times 1 is square root of 2. And 2 times 2 is 4. So since these two fractions have the same denominator, we can just subtract the terms in the numerator straight across. So we end up with square root of 6 minus square root of 2 over 4. And that is our final answer. So the cosine of 75 degrees is equal to the square root of 6 minus the square root of 2 all over 4. Let's try another one. Let's say we want to find the sine of 105 degrees. Well, we can rewrite that to be the sine of 60 degrees plus 45 degrees. Now, if we refer to our sine of A plus B formula over here, we can see that it's equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. So we can write that as the sine of A, so in this case A is 60 degrees, times the cosine of B, so B is 45 degrees, plus the cosine of A, so the cosine of 60 degrees, times the sine of B, B is 45 degrees. So now, once again, if we think about our unit circle, if we think about our 45-degree angle, the xy coordinates on the unit circle at 45 degrees are square root of 2 over 2 and square root of 2 over 2. And for 60 degrees, our xy coordinates are 1/2 and square root of 3 over 2. And remember, the x coordinate corresponds to cosine, while the y coordinate corresponds to sine. So the sine of 60 degrees would be the y coordinate, or square root of 3 over 2. Then we have times the cosine of 45 degrees. So the cosine of 45 degrees is square root of 2 over 2. And then we have plus the cosine of 60 degrees. So the cosine of 60 degrees is 1/2 times the sine of 45 degrees. So the sine of 45 degrees is square root of 2 over 2. So let's go ahead and multiply these values. The square root of 3 times the square root of 2 is the square root of 6. In the denominator, we have 2 times 2, that's 4. Plus, over here we have 1 times the square root of 2, that's just the square root of 2. And in the denominator, we have 2 times 2, that's 4. So notice that these two fractions have the same denominator, so we can just add the values in the numerator straight across. So our final answer will be square root of 6 plus square root of 2 over 4. So the sine of 105 degrees is the square root of 6 plus the square root of 2 over 4. All right, let's try one more example. Let's say we want to find the tangent of 15 degrees. Well, we can rewrite this as the tangent of 45 degrees minus 30 degrees, since 45 minus 30 is equal to 15. So let's refer to our tangent subtraction identity right here. So we have the tangent of a minus b is equal to the tangent of a minus the tangent of b divided by 1 plus the tangent of a times the tangent of b. So let's go ahead and write that. We have the tangent of a, so in this case a is 45 degrees, minus the tangent of b, b is 30 degrees, all over 1 plus the tangent of a, so tangent of 45 degrees, times the tangent of b, which is 30 degrees. Okay, so to fill in some of these values, let's think about our unit circle again. At 30 degrees, the xy coordinates on the unit circle are square root of 3 over 2 and 1/2. And at 45 degrees, the xy coordinates on the unit circle are square root of 2 over 2 and square root of 2 over 2. And remember, the x coordinate corresponds to cosine, while the y coordinate corresponds to sine. So you need to know that the tangent of an angle is equal to the sine over the cosine. So if we want to find, say, the tangent of 45 degrees, we need to do the sine of 45 degrees, which is square root of 2 over 2, and divided by the cosine of 45 degrees, which is also square root of 2 over 2. So since the numerator and the denominator are the exact same values, this whole fraction just simplifies to 1. So the tangent of 45 degrees is 1. So we'll write 1 minus, and then we need to find the tangent of 30 degrees. So the tangent of 30 degrees, that will be sine over cosine once again. So we'll have 1/2 divided by square root of 3 over 2. And remember, when we divide fractions, that's the same as multiplying by the reciprocal. So when we do that, these 2's will cancel out, and we're left with 1 over root 3. So the tangent of 30 degrees is 1 over root 3. Now in the denominator we have 1 plus the tangent of 45, which we just found was 1. And that's getting multiplied by the tangent of 30, which we just found was 1 over square root of 3. So let's erase some of this so we have some more room to work with. Okay, so here's where we're at. We have 1 minus 1 over root 3 divided by 1 plus 1 over root 3. So before we move on, it helps if we can rationalize the denominator of these fractions. So we do that by multiplying the numerator and the denominator both by root 3. So let's do that. And when we do that, the denominator, root 3 times root 3, just becomes 3. And the numerator becomes root 3. So this whole thing can be rewritten as 1 minus the square root of 3 over 3 over 1 plus the square root of 3 over 3. So now we want to try to get these 3's out of the denominator. So what we can do is we can multiply the entire numerator by 3 and the entire denominator by 3. So when we do that, we get 3 times 1 in the numerator, so let's write it over here, 3, minus, notice that when we do 3 times this whole expression, these 3's will cancel out, and we'll just be left with root 3. So 3 minus root 3. And in the denominator, when we distribute this 3, we'll get 3 plus, And once again, these 3's will cancel out, so we'll just be left with root 3. Okay, so how can we simplify from here? Well, we can do something known as multiplying by the conjugate, and that would be this first term minus the second term. And the reason that we do that will become clear in just a minute. But let's multiply the numerator and the denominator by the conjugate. So we'll say minus root 3, and we'll multiply the denominator by 3 minus root 3. So when we do that, we'll get 3 times 3, that's 9. And then we have 3 times negative root 3, so that's minus 3 root 3. And then we get negative root 3 times 3, so minus 3 root 3. And then negative root 3 times negative root 3, that is just positive 3. And in the denominator, we have 3 times 3, that's 9. Then we have 3 times negative root 3, so minus 3 root 3. And then we have root 3 times 3, so we have plus 3 root 3. And then square root of 3 times negative square root of 3, so we get minus 3. So we can see that this negative 3 root 3 and positive 3 root 3 will cancel out. And that's the nice thing about multiplying by the conjugate, is that always happens. So we're just left with two terms. It's 9 minus a 3. So we get, in the numerator, we have 9 plus 3, that's 12. And then we have a negative 3 root 3, negative 3 root 3, so that's negative 6 root 3. And in the denominator, all we're left with is 9 minus 3, that's 6. So we can rewrite this expression, we can break it apart and say 12 over 6 minus 6 root 3 over 6. And when we do that, we can simplify and say 12 divided by 6, that's 2. 6 root 3 over 6, these 6's will cancel out, and we're just left with minus square root of 3. So the final answer is 2 minus the square root of 3.